Well, hello algebra students and welcome to the first video covering lesson 3.1 on relations and functions. We are beginning topic 3 covering linear functions, and we have a lot of vocab to discuss. We are going to talk about relations and this big topic of functions. Functions is a huge topic in algebra, not only in algebra 1 but in algebra 2 and pre-calc if you continue on in your math journey. So let's get right to what function might be. So example 1, recognize domain and range. What are the domain and range of the function? Oh my goodness. So if you take a look here, we have we call it input-output table, right? The x's are what we call the inputs, and the y's are what we call the outputs. Well, a relation is a set of ordered pairs. These are ordered pairs. 1, 11, 2, 12, 3, 13. They're all points on a graph. If this relation is a function is a relation in which each input is assigned to exactly one output. This is a huge deal. A huge deal, right? The domain and range are two sets of numbers within a function or a relation. The domain are going to be our inputs. So if you look up here in this table, the inputs are the domain values. And our range, I'll change colors, our range is going to be the set of output values. So our outputs here are going to be, the range. Okie-doke. So as you can see in the table, typically your domain are the x values. So down here it says, by convention, the inputs are your x values. Do it in a box. And your outputs are the y values. Okay? Alright, so again, this is huge. These are huge notes right here. Big stars. Big star. This star. It's off to the side. So let's talk about it. So what would the domain be for this graph? Or for this relation? So the domain here, we will put domain. We'll put a colon and a brace. And we're going to list the numbers in the domain from least to greatest. So that'd be 1, 2, 3, 4, and 5. We'll do the same thing in the range. So we'll put the word range, put a colon, we'll use a brace. Now in the range, I see that the 13s repeat. We're not going to write 3 13s in the list of range. We're going to put 11, 12, and then 1 13, and that's good enough. So here, there's no need to repeat. No need to repeat. And there is your domain and range. Now, as a bonus to this question, let's talk about this idea of a function. I'm going to make what's called a mapping diagram. I'm going to put my inputs here, inputs, and my outputs over here. So my inputs were 1, 2, 3, 4, and 5. And my outputs, my range, were 11, 12, and 13. And I'm going to draw arrows connecting my input value, my range, my input value, my x, to my output value, my y. So 1 is connected to 11. 2 is connected to 12. 3 is connected to 13. And so is 4, and so is 5. Okay? So if we take a look here, again, by definition, a function is a relation in which each input is assigned to one output. This 1 is assigned to 11. This 2 assigned to 12. This 3 to 13. This 4 to 13. This 5 to 13. Each of those input values only goes to one output. This would be a function. So this relation is a function, and it's because each input has only one output. Sorry for the sideways writing. I don't know. My thing's kind of turned. Function because each input has only one output. And again, the idea is that you only have one arrow going from each of these input values. All right. So I think we'll do another function here in a little bit, but just wanted to kind of emphasize the idea of a function. It's a big deal in this section. All right, so this is a huge slide right there. Very, very, very important. Okay. All right, next, let's talk about Oh yes, domain and range is more. So it says a function can model each situation. What is a reasonable domain and range of each function? So again, what is a reasonable domain and range? So this one, it says a hose fills a 10,000-gallon swimming pool at a rate of 10 gallons per minute. So when you take a look at this rate, so we talked about slope in topic 2. Rate is the same thing as slope, and we should know that slope is the change in y, or the y's, over the x's, rise over run. So when we look at this gallons per minute, the y is going to be gallons. This per is the fraction. That's that slash, gallons per minute, and minute is our x's. So when we try to talk about what our domain is going to be, our domain is going to be time. X minutes. And of course, if we're trying to fill a swimming pool, it's going to start at 0 minutes, right? When we start, and it's going to last until we fill the pool. So a reasonable domain for this first one is 0 minutes to the total time to fill the pool. So this is really trying to get you guys to pair these vocab words with real-life situations. Now the range is now going to be how many gallons are in the pool. So of course, you start at 0 gallons, and you're going to go till it's full. Well, this is a 10,000-gallon swimming pool, so we're going to go to 10,000 gallons. And again, we stop at 10,000 because that is the total capacity for this swimming pool. Capacity is how much something can hold. Capacity. And there we go. So there's our first one. Second example here. A restaurant needs to order chairs for its tables. One table can accommodate 4 chairs. So in my opinion right here, when it says one table can accommodate 4 chairs, you first set the tables out. The tables are what we call our independent variable. I'm going to write that down here. That's what we choose. And then once we set out a table, each table needs 4 chairs. So our domain here are going to be the tables. And if you have no tables, it's 0. And now you can't have half a table, but you can have then 1 table, 2 table, 3 tables, and you can keep counting. So it's just these whole numbers, okay? And again, what this represents is the number of tables. And as I just mentioned, this would be what we call our independent variable, because what we're doing is we're choosing how many tables to put out there. Independent variable. So then your range would then be the chairs going around the table. So of course, if there's 0 tables, there's 0 chairs. But then once you have 1 table, 4 chairs go at that table. And then if you have 2 tables, that'd be 8 chairs, right? 3 tables, that'd be 12 chairs. And so on and so on. This would be the number of chairs. And because this depends on how many tables we have, we call this the dependent variable. Dependent variable. And of course, the ... means you keep going, and you would stop at the table capacity. Capacity for the restaurant. Right? So you can't overfill the restaurant with tables. Cool. All right, so again, that's talking about domain and range for real-life situations. Very important when we do word problems to think about that. All right, last one here on this video. So now let's talk about is the domain for each situation continuous or discrete? So the domain of a function is continuous when it includes all real numbers. So continuous means all real numbers. So that means, 3, 7.9, 2.54, right? It can be any number real, all right? This means that the graph would be a line or a curve. It's going to be one single piece of, whatever. Pencil never leaves the ground, line or curve. For a graph to be a discrete, it would consist of just whole numbers or integers. So here, you're not going to include every real number. It's going to be nice numbers, right? And again, here the graph is just a series of points. So it's just a bunch of points. Okay. So if we take a look at each one here, and this is a big deal, right? This idea of discrete versus continuous, right? Big deal. So if we look here at this first one, so the hose filling up the gallons of the 10,000 gallon swimming pool, you can see that this is a continuous graph. It is one line. Continuous. Let me write that again. Continuous. Sorry. There you go. Right? One long line. Starting at 0, 0, because if time hasn't gone by, you're not filling it up at all. Let me move this up so you can see the x-axis time and then volume. Over here with the tables and chairs, notice that this is going to be a discrete graph. It's a series of points. And again, as we noted up above, or in the previous example, it was counting by nice numbers, right? 0, 1, 2, 3, 4, 5 for the tables, and 0, 4, 8, 12, 16 for the chairs. Nice. Okay, this is the end of video 1. Video 2 is coming up right next.